This is Dreamtime Science, where tonight's most interesting discoveries become tomorrow's dreams. I've got something particularly engaging to share with you. You know, I've been thinking about something quietly amazing, how the universe, this vast and beautiful place we're part of, might one day come to an end. There's something remarkable about imagining such a distant future, not with fear, but with a kind of peaceful curiosity about how all the stars and galaxies might gently wind down their stories. I'm looking forward to sharing some ideas that are as surprising as they are comforting, and I think you'll find them quietly fascinating too. If this peaceful blend of science and serenity helps ease your evening, consider joining our community of gentle learners. Share your favorite moment of scientific awe in the comments. Take this moment to settle in, wrap yourself in comfort, release the day's weight from your shoulders, and let your breath become as gentle as starlight. How gently the night falls outside your window, the world settling under the hush of darkness, each star a quiet sentinel overhead. It is in these hours, when the bustle of the day has faded, that the mind sometimes wanders further than the boundaries of towns, fields, or even the planet itself. Perhaps you have gazed into the velvet canopy and wondered, not only about the origins of the universe, but about its destiny. What lies beyond the reckoning of ages in the deep future, where the flame of existence itself threatens to flicker out? This is the threshold where our story begins. At the dawn of the universe's ending, a stage set for a drama too vast, too slow, and too inexorable for any mortal audience to ever witness in full. We are creatures of stories. For as long as language has crackled in our throats and pictures danced on cave walls, we have told tales of endings, of floods that wipe the land clean, fires that consume the world, gods who tire of their own creations. The apocalypse in all its forms is an old companion. It is in the fearful churn of myth and legend, in the cryptic prophecies of ancient texts and the fevered visions of seers. Even today, in the flickering glow of our screens, we cannot help but imagine the end. Worlds shattering, galaxies colliding, civilizations swept away by cosmic storms. These stories, colored by hope and terror, are more than entertainment. They are the means by which we grapple with the unknowable, the immense, the inevitable. Yet, as science has unfurled the universe before us in ever greater detail, the shape of the end has shifted. The old myths, for all their poetry, are too small to contain the cosmos as we now understand it. No angry deity will snuff out the stars with a careless gesture. No single cataclysm, no sudden curtain fall awaits us in the wings. The universe is not a stage built for human drama, nor is it likely to end in a way that centers human fears or hopes. Instead, we are invited to contemplate an ending of a different kind, one measured not in days or centuries, but in eons stacked upon eons, an unraveling as patient and indifferent as the turning of the heavens themselves. Consider for a moment how the idea of the end of everything has haunted the imagination. In medieval Europe, the end was a day of fire and judgment, the final trumpet blast that would call forth the bones of the dead. In the Norse sagas, Ragnarok was a battle of gods and monsters, the sky split by lightning, the world drowned and then reborn. The Maya counted down the Bactans, their calendar spiraling toward a moment of cosmic renewal. Even in the silent spaces between stars, we have projected our longing for an ending, a sense of closure that gives meaning to the narrative of existence. It is not only religion or myth that has pondered these questions. The storytellers of modernity, writers, filmmakers, artists, have spun their own visions of doom. Apocalyptic fiction is a mirror for our anxieties. The ticking clock of nuclear war, the creeping dread of environmental collapse, the terror of cosmic annihilation. But beneath every story is the same pulse, a yearning to know how and when and why the cosmos will finish its great performance. Is it a bang, a whimper, a freeze, or a fire? To begin to answer these questions, we must first sweep aside the clutter of misunderstanding. The end of the universe, as understood by science, is not an apocalypse in the human sense. There is no single day marked in some celestial calendar when all things will end in a fiery crescendo. Instead, the fate of the cosmos is written in the language of physics, a tapestry woven from the properties of matter and energy, the shape of space, and the unyielding laws that govern their dance. The universe is not a play with a neat final act, but a process, a journey whose conclusion is spread across unimaginable stretches of time. For most of human history, our sense of cosmic time was parochial, hemmed in by the brief span of lives and the slow crawl of generations. The world was thought to be eternal, or nearly so, cycling endlessly through creation and destruction. Only in the past century did we begin to glimpse the true scale of cosmic history, and with it the possibility of a true ending. When Edwin Hubble looked out at the nebulae, what we now know as galaxies, he found them flying away from us, the space between them swelling. The universe, it seemed, was expanding. That discovery, simple in its observation, profound in its implications, cracked open a new domain of questions. If the universe is growing, what was its beginning, and what will be its end? The expansion of the universe is the silent metronome by which all things tick. It is not just the galaxies that move. Space itself stretches, pulling the fabric of reality ever tauter. With this knowledge came the realization that the cosmos is not static, but dynamic. It began, it evolves, and, most tantalizingly of all, it will end. But how? Here, the scientific imagination unfolds in a spectrum of possibilities, each one a theory as grand and strange as the myths that came before. There is the heat death, a phrase that chills the bones with its quiet finality. There is the Big Rip, a scenario as dramatic as any Ragnarok, rending everything from galaxies to atoms. Some dream of a big crunch, a cosmic return to the beginning, or even a big bounce, a universe that cycles between death and rebirth. Each theory is rooted in the laws of physics, our best attempt to project the present into the abyss of the future. To understand these endings, we must set aside the apocalyptic visions that populate our stories. The universe will not perish in an instant, nor will it heed the desires of any living thing. The end, if it comes, will be vast, slow, and implacable, unfolding over timescales so immense that even the hardiest stars will have long since exhausted their fuel. It is a drama measured not in the rise and fall of empires, but in the cooling of suns and the fading of light itself. Yet for all their strangeness, these scientific visions share a kinship with myth. They are our modern attempt to peer beyond the horizon of knowledge, to grasp at the edges of what can be known. The universe's end is a riddle posed by nature, and we, brief sparks in the darkness, have dared to ask it. To dispel the first and most persistent myth, there will be no sudden, all-consuming apocalypse. The universe does not operate on a human schedule. Its fate is determined not by prophecy or divine decree, but by parameters we can, in principle, measure. The total amount of mass and energy, the nature of dark energy, the laws that govern the smallest and largest scales. If there is a day of judgment, it is not marked in any calendar, but written in the slow accounting of entropy, the endless balancing of expansion and gravity. Some imagine the end as a great fire, the stars burning brighter and brighter until they burst, consuming all in their path. Others picture a freeze, a darkness so complete that not even the memory of light remains. Still others dream of collapse, the universe falling back upon itself, erased in a final act of cosmic compression. Each of these images contains a seed of truth and a measure of misunderstanding. The heat death, also known as the Big Freeze, is perhaps the most widely accepted scenario and also the most haunting. It is not a death by fire, but by cold, a gradual dimming as stars exhaust their fuel and the embers of creation cool to darkness. In this vision, the cosmos becomes ever more diffuse, its energy spread thin, its capacity for change exhausted. Galaxies drift apart until they vanish from one another's sight, each island of stars growing lonely. Black holes, the last bastions of structure, eventually evaporate, leaking away their mass in a slow drizzle of radiation. In the fullness of time, all that remains is a thin, chilly soup of particles spread across a space grown vast beyond comprehension. Change becomes impossible, and the story of the universe ends not with a bang, but with a whisper. But there are other possibilities, each as mesmerizing as it is strange. In the Big Rip, the expansion of the universe accelerates without bound, driven by a mysterious force known as dark energy. This expansion does not merely carry galaxies away from one another. It tears apart the very fabric of space, shredding stars, planets, and eventually even atoms. It is a vision of dissolution, where the bonds that hold matter together are unraveled by the restless growth of the cosmos. Or perhaps, say some theorists, the expansion will one day halt and reverse. Gravity, the tireless sculptor of structure, may someday gather enough strength to pull the universe back in upon itself. In this big crunch, galaxies race together, stars collide, and all matter is crushed to a final, fiery singularity, a return to the dense, hot origins from which everything sprang. Some dream even further, that this collapse might be followed by a new explosion, a big bounce in which the cycle of creation and destruction repeats forever. Beneath all these scenarios lies a profound humility. The cosmos is not ours to command or to comprehend in full. Our place within it is brief, our understanding partial. Yet in the span of a single lifetime we have learned to ask questions as old as the stars and to seek answers in the language of mathematics and observation. The end of the universe is not a fairy tale or a fable. It is a scientific question, rooted in evidence, open to revision as our knowledge grows. As we drift deeper into this exploration, we must hold two truths in our minds. The end of everything is not a story written for us, and yet, by seeking to understand it, we claim a measure of kinship with the cosmos. We are its children, born of its dust, shaped by its laws. In contemplating its fate, we are, in a sense, contemplating our own. The curtain rises, then, not on a play that promises drama and spectacle, but on a vast, slow unfolding, the patient transformation of all that is, governed by laws older than stars, indifferent to hope or fear. In the chapters to come, we will trace these possibilities in greater depth, peering into the heart of entropy, the mystery of dark energy, and the strange fate that awaits even the mightiest galaxy. The night is long, and the story has only just begun. Across the silent tapestry of night, the universe reveals itself as a vast and enigmatic stage, where stars, galaxies, and time itself perform an endless ballet. The mind drifts, eager to pierce through the veil of darkness, to watch this cosmic choreography unfold. In the quiet hush between heartbeats, the questions that guide astronomers and dreamers alike begin to shimmer. How do the stars live and die? How do galaxies spin and spiral, drawn together and torn apart by unseen hands? And what is time, that silent measure by which all things come and go, stretching and fold? Across the expanse of space, begin, if you will, with a single star, a distant sun, far from our own, yet obeying the same relentless laws. A star is a furnace, yes, but so much more. It is a crucible of creation, a testament to the subtle balance between gravity's inexorable pull and the fierce outward pressure of nuclear fire. In its heart, hydrogen atoms are pressed so tightly that their very nature changes. They fuse, merging to form helium, and in the process releasing energy that journeys outward, layer by layer, until it escapes as light. This is a process that takes millennia. A photon created at the core may spend hundreds of thousands of years ricocheting outward, weaving between atoms, before it finally bursts free into the universe. The energy that emerges from a star is not merely light to warm planets or guide the lost. It is information, a message encoded in the spectrum of radiation, whispering secrets about temperature, composition, and age. Astronomers, ever the cosmic detectives, catch these ancient photons in their telescopes, decoding the stories they carry from across unimaginable distances. In the faintest glimmer, one can read of elements forged in the star's depths: carbon, oxygen, iron. It is in stars, after all, that the raw materials for life itself are assembled, atom by atom, over the slow, patient course of eons. Yet the life of a star is not eternal. There is a rhythm to its existence, dictated by mass and fuel. A small star, like a red dwarf, may burn for trillions of years, sipping its hydrogen with frugal care, glowing with a steady, subdued light. A massive star, by contrast, lives fast and dies young. Its brightness is a beacon, but also a warning. Such brilliance cannot last. When its core becomes choked with heavier elements, carbon, then oxygen, then iron, a transformation begins. Fusion can go no further, for iron is a dead end, a nucleus that absorbs rather than releases energy. Deprived of its outward pressure, the star's core collapses under its own gravity in a fraction of a second, and the outer layers rebound in a cataclysmic explosion, a supernova. In that moment, the universe is awash with new elements, gold, silver, uranium, hurled into space to seed future generations of stars and planets. Sometimes the remnant core becomes a neutron star, a city-sized sphere so dense that a teaspoon of its matter outweighs a mountain. Or, if the star is massive enough, gravity wins utterly, and a black hole is born. These are not merely the deaths of stars. They are the sowings of cosmic fields, where new systems may arise. The debris of ancient explosions drifts through space as clouds of gas and dust, gathering and collapsing under gravity's persistent whisper until the cycle begins anew. Thus, each star is a note in a symphony that stretches across billions of years, an echo of explosions and rebirths whose harmonies shape the evolution of galaxies themselves. Galaxies, those sprawling cities of stars, spin and swirl, drawn together by gravity, yet each a mystery in its own right. From our vantage point on a minor spiral arm of the Milky Way, we can only marvel at their diversity. Some, like our own, are grand spirals, with arms unfurling in luminous ribbons, dust lanes tracing the paths of nascent stars. Others are ellipticals, vast and featureless, home to ancient, dying suns. And still others are irregular, shaped by collisions, tidal forces, and the unpredictable currents of intergalactic space. But within this dance arises a question that has troubled astronomers for a century. When we gaze at a galaxy, we can measure the speed at which its stars orbit the center. The outer stars, far from the galactic core, should move more slowly, just as planets farther from the Sun orbit at a gentler pace. Yet observations defy this expectation. The stars on the outskirts of galaxies move far too swiftly, as if some invisible mass holds them in thrall, binding them more strongly than the stars and gas we can see. This missing mass, inferred from movement and not from light, we call dark matter. It is a name born of ignorance, a placeholder for something utterly real and yet, to our senses, completely intangible. Dark matter neither emits nor absorbs light. It does not interact with electromagnetic forces. It is, for all practical purposes, invisible, yet its gravitational pull is undeniable. Through its influence, galaxies are held together, galaxy clusters are sculpted, and the great filaments of the cosmic web are woven. Without dark matter, the universe as we know it would be impossible, its structures fleeting and fragile, scattered to the void by their own centrifugal energies. What then is dark matter? Theories abound. Some suggest it is made up of as yet undiscovered particles, weakly interacting massive particles, or perhaps axions, or even primordial black holes. Others propose modifications to our very understanding of gravity, whispering that the laws we hold so dear may not be as universal as we think. Yet in the darkness, the answer eludes us. Every experiment to trap or glimpse a dark matter particle has thus far come up empty. Like a shadow at the edge of a lamp's glow, it recedes whenever we approach. If dark matter is the silent scaffolding upon which the universe is built, there is another, even more mystifying player in this cosmic drama, dark energy. Where dark matter binds, dark energy drives apart. Its existence was first betrayed by the distant light of supernovae, those dying stars whose brilliance can serve as cosmic lighthouses. In the late 20th century, astronomers measured the light of such supernovae in far-flung galaxies and found, to their astonishment, that the universe is not merely expanding, but accelerating, as if some invisible force were pushing it ever outward, faster and faster with time. This repulsive force, which dominates the energy content of the universe, we call dark energy. It is not energy in any familiar sense, but rather a property of space itself, a pressure woven into the very fabric of the cosmos. It is the most profound enigma facing cosmology, for it means that the fate of the universe is not merely to drift apart, but to rush ever more swiftly into emptiness, the galaxies receding beyond sight, the stars growing cold and dim. Time, in this grand story, is more than just a background against which events unfold. It is woven into the very structure of reality. In Einstein's general relativity, space and time are not separate, but interlaced into a four-dimensional fabric, space-time. Mass and energy warp this fabric, bending the paths of planets, stars, and even light itself. The gravity we feel is not a force in the traditional sense, but the result of moving along the curved geometry shaped by massive bodies. Time, too, is relative. Its pace can be stretched or compressed. Near a massive object, such as a star or black hole, time slows down. In the depths of intergalactic space, it runs more freely. This relativity of time has profound consequences. Consider the journey of a photon leaving the heart of a distant galaxy, traveling across billions of years to reach our telescopes. To us, that photon has been in flight for an age. But from the photon's perspective, traveling at the speed of light, the journey is instantaneous. It does not experience time at all. Thus, in the act of observing the universe, we become witnesses to the past, peering back across epochs with every glance skyward. The light from distant galaxies shows us what they were, not what they are. The further we look, the further back we see. Yet time is also a mystery at the heart of physics. Why does it flow only one way, from past to future, when the fundamental laws are almost indifferent to direction? The answer may lie in entropy, in the gradual increase of disorder that gives the arrow of time its relentless push. Or perhaps it is written into the initial conditions of the universe itself, a primal asymmetry that still echoes in the ticking of every clock. The interplay of these elements, stars forging elements in their fiery cores, galaxies swirling in the grip of invisible matter, time stretching and folding, dark energy urging the cosmos toward ever greater emptiness, forms a story that is both breathtaking in its grandeur and humbling in its mystery. The limits of our comprehension are not barriers, but invitations. Each unanswered question is a doorway, beckoning us onward into deeper realms of wonder. We are, in a very real sense, the universe made conscious, able to ask these questions, to marvel at the beauty and strangeness that surrounds us. Yet for all our understanding, for every equation solved and observation made, the cosmos remains a place of shadows and secrets. The dance of stars and time is far from over. Indeed, it is only just begun. New telescopes pierce the darkness, fresh theories are born, and the night sky remains undimmed, a canvas for curiosity without end. As the night deepens and the mind drifts, one cannot help but feel the pull of these mysteries. The stars overhead shine with ancient light, each a whisper from a time before our own. The galaxies wheel in slow, majestic spirals, their motions dictated by forces unseen. The fabric of space-time itself stretches and swells, carrying us all forward into an unknown future. And beneath it all, the questions hum, unresolved, promising that there is more yet to discover, more yet to understand. The universe is not a static tableau, but a living, evolving entity. Every star that is born, every galaxy that collides, every quantum fluctuation in the darkness contributes to a story that is still being written. In the delicate balance of forces, gravity and expansion, light and darkness, order and entropy, the cosmos continues its silent dance, inviting us to watch, to learn, and to wonder. The next steps in this journey lie ahead, just out of sight, waiting in the space between dreams and waking, where the boundaries between what is known and what is possible blur and dissolve. In the gentle hush of a sleepless night, when the world around you lies cloaked in shadow and the stars prick the heavens with their icy fires, a certain quiet wonder can take hold. It is in these hours that the mind, untethered from the demands of the day, may drift ever outward, past the boundaries of our pale blue world, past the silent ballet of the planets, out into the fathomless dark. Here, in this cosmic sea, we find ourselves both infinitesimal and privileged, for we are among the universe's rarest observers, able to question not only where we came from, but also where we and the cosmos itself are destined to go. It is a rare and peculiar thing, this urge to peer into the universe's future. For most of human history, our gaze was turned backward or downward. Hunter-gatherers reading the tracks of prey, ancient astronomers tracing the cyclical dance of stars and seasons. And yet, as our tools have grown sharper and our questions more audacious, we have begun to look forward, to dare to ask how the grand story might end. It is a question both scientific and poetic, one that demands the rigors of mathematics and the humility of the imagination. The tools we employ in this grand divination are many, and each is itself a marvel. One might think of the astronomer's telescope first, that curious marriage of glass and precision that brings distant galaxies tumbling into view. But in truth, the most profound instruments are sometimes invisible, woven from the fabric of mathematics and logic. Let us begin, if we may, with the most silent and powerful of these, the equations that underlie all of modern cosmology. At the heart of our understanding lies the general theory of relativity, penned by Albert Einstein in the early 20th century. This was not merely a tweak to Newton's venerable vision of gravity, but a revolution in the way we understand space and time themselves. In Einstein's hands, the universe became a flexible thing, a vast four-dimensional tapestry that could bend and curve under the weight of mass and energy. Planets and stars, galaxies and clusters, all traced their paths along these curves, like dancers gliding across a warped floor. But relativity offered more than an explanation of gravity. It gave birth to a new kind of prediction. If space and time are intertwined, and if mass can curve them, then the universe itself must obey certain rules about how it expands, contracts, or changes over time. The equations that describe this, the Friedmann equations, derived from Einstein's own, became the first real tools for peering into the cosmic future. They tell us, with mathematical precision, how the universe's fate hinges on its contents. the invisible dark matter, the mysterious dark energy, the ordinary atoms of stars and dust, even the subtle pressure of radiation. For decades, cosmologists worked with these equations, feeding them with what little data they could glean. They measured the expansion of the universe, tracked the faint afterglow of the Big Bang, and counted the galaxies that wheeled through the night. Each observation served as a clue, a whisper from the ancient past about what might yet come to pass. For a time, it seemed the universe might be doomed to collapse in a great reversal, a big crunch, or else drift eternally, its expansion slowing but never quite stopping. Each possibility was a story written in the language of numbers and probability, and the evidence seemed to favor neither ending with certainty. To refine these predictions, scientists turned to ever more exquisite tools. The telescope, of course, remained indispensable. First, there were ground-based telescopes, vast and stately, perched atop lonely mountains, where the air is thin and the stars shine undimmed. Later came the space telescopes, like the venerable Hubble, freed from the shimmer and distortion of Earth's atmosphere, able to gaze farther back in time than any eye before. With their help, astronomers assembled a kind of cosmic fossil record, light from galaxies so distant that they reveal the universe as it was billions of years ago. By measuring how much the light from these galaxies is stretched, a phenomenon known as redshift, they could map the history of cosmic expansion itself. It was here, in the closing years of the 20th century, that one of the most astonishing discoveries in science was made. Teams of astronomers, peering into the remote past using distant supernovae as cosmic mileposts, found that the expansion of the universe was not slowing, as gravity ought to demand, but rather accelerating. The very fabric of space was being pushed apart by some unseen force, a pressure woven into the vacuum itself. This revelation forced a radical rethinking of the cosmic crystal ball. The universe was not gently coasting or teetering on the edge of collapse. Instead, it was racing ever outward, driven by something Einstein himself had once posited and then abandoned, the cosmological constant, or what we now call dark energy. The evidence for dark energy, though indirect, became overwhelming. It was not only supernovae, the cosmic microwave background, the ghostly afterglow of the Big Bang, revealed subtle patterns that only made sense if dark energy were real. The distribution of galaxies across the sky, mapped in ever greater detail by surveys like the Sloan Digital Sky Survey, showed the fingerprints of a universe shaped by this mysterious force. The arithmetic of the cosmos had changed, and with it our predictions for its fate. But as with all good mysteries, each answer only bred new questions. What is the nature of dark energy? Is it truly constant, as Einstein's equations suggest, or does it change over time? Could the acceleration one day reverse, or might it speed up until the very fabric of atoms is torn asunder, a cataclysm some call the Big Rip? To answer such profound questions, scientists have had to devise ever more ingenious ways of peering into the future, drawing on the full arsenal of modern science. One method is the careful observation of the cosmic microwave background, that faint bath of radiation that fills all of space. Born just 380,000 years after the Big Bang, it is the oldest light in the universe, a kind of cosmic photograph of our infancy. By measuring its tiny fluctuations, regions just slightly warmer or cooler than their neighbors, cosmologists can infer the density, composition, and age of the cosmos with extraordinary precision. Satellites like COBE, WMAP, and most recently Planck have mapped these subtle ripples with increasing detail, turning the sky into a treasure map of cosmic history. Each new map refines our understanding of the universe's ingredients and thus its destiny. Alongside these observations, theorists work with powerful computers, simulating billions of years of cosmic evolution in digital universes that span hundreds of millions of light years. These simulations are not mere visualizations. They are experiments in the truest sense, governed by the same laws of physics that rule our own world. By comparing the results of these virtual universes with what we observe through telescopes, scientists can test which theories best match reality and which futures remain possible. Yet for all their power, neither observations nor simulations offer certainty. The universe is a complex and subtle thing, and its fate may hinge on details we have yet to discover. For instance, the fate of the cosmos depends critically on the properties of dark energy, a substance we can measure only indirectly and whose true nature remains elusive. If it is truly constant, the expansion will continue forever, stars will burn out, and galaxies will drift apart into a cold and silent night. But if dark energy evolves, or if other exotic physics is at play, the future could take a stranger course. One possibility is the so-called Big Rip. In this scenario, the strength of dark energy increases over time, eventually overwhelming all other forces. Galaxies would first be torn apart, then solar systems, then planets, and finally atoms themselves, as the very structure of matter is unraveled by the accelerating expansion. Though the evidence presently suggests this is unlikely, the sheer strangeness of the universe's ingredients means it cannot be ruled out entirely. There are other possibilities too, some drawn from the most speculative reaches of theoretical physics. In certain models, the vacuum of space is not truly stable, but rather perched in a temporary state. If this false vacuum were ever to transition to a lower energy state, it could unleash a bubble of destruction that would race across the cosmos at the speed of light, rewriting the laws of physics in its wake. This is called vacuum decay, and while it is a distant and uncertain prospect, it is a reminder of how much we have yet to learn. Beyond the physics, there is also the question of time itself, a dimension we experience in one direction only, but which may be stranger than we imagine. Some theories propose that the arrow of time is connected to the universe's expansion, and that as the cosmos grows older and colder, the very flow of time may change or cease in ways we cannot yet fathom. Others suggest that new universes might bud off from our own, in a cosmic cycle without end, each with its own laws and destinies. To probe such mysteries, scientists have begun to look for new kinds of evidence. They study the distribution of galaxies and clusters, searching for subtle signs that the expansion rate is changing. They hunt for gravitational waves, ripples in space-time itself, emitted by colliding black holes and neutron stars, hoping to glimpse physics beyond Einstein's equations. They scan the heavens for the faintest signals, from the decay of protons to the whisper of neutrinos, each a potential clue to the universe's ultimate fate. The work is painstaking, often slow, and sometimes frustrating. The universe does not yield its secrets easily, and each discovery seems to open fresh avenues of uncertainty. But there is a quiet, persistent hope at the heart of the endeavor, that by gathering more data, refining our theories, and building ever more sensitive instruments, we may at last glimpse the outlines of our cosmic future. It is a hope born not of arrogance, but of curiosity, a recognition that to ask about the end is, in some small way, to honor the vastness and mystery of what has come before. In all this, it is worth remembering that our predictions are not prophecies, but extrapolations, lines drawn forward from the evidence we have, in the hope that the laws of physics are as steady and universal as they appear. The universe is under no obligation to conform to our expectations, and the unknown may yet hold surprises. But the very act of questioning, of peering into the cosmic crystal ball, is itself a triumph of the human spirit. So, as the night deepens and the stars wheel overhead, we find ourselves poised on the threshold of knowledge and wonder. The telescopes may rest for now, the equations may sleep in their books, but the questions remain, alive and luminous, like distant galaxies shining in the dark. The future is unwritten, the end uncertain, but the journey of discovery continues, ever onward, ever outward, into the waiting night. And somewhere in that darkness perhaps the next clue, the next cosmic whisper awaits to be found. In the hush that follows the cosmic crescendo, where the last embers of starlight dwindle into the unseen, a profound silence begins to enfold the universe. It is not the silence of mere emptiness, but a deep and resonant pause, a symphony of silence echoing across gulfs of time and space, bearing witness to all that has been and all that is yet hidden in the shrouded folds of existence. Here, on the far shores of cosmic history, we find ourselves drawn irresistibly to reflection, standing as conscious beings within the brief flicker of warmth and meaning that the universe has known. The end of the universe is not just an astronomical event, nor merely the fading of matter and energy. It is a philosophical mirror, inviting us to peer into the very nature of reality, of self, and of the mysteries that defy our grasp. To contemplate the universe's final bow is to confront the ultimate dissolution of boundaries, between star and void, between the known and the ineffable, between the observer and the observed. As the last galaxies slip beneath the cosmic horizon, their light stretched and cooled beyond all recognition, the stage is set for an era where entropy reigns supreme. Yet entropy, that silent scribe of the universe's fate, writes its story, not just in the scattering of matter, but in the quiet persistence of memory and meaning, wherever consciousness has arisen to bear witness. It is a strange comfort, perhaps, to know that after the fevered dance of galaxies and the brief flaring of stars, the universe will enter a state not of chaos, but of order, albeit an order so diffuse and absolute that it becomes indistinguishable from stillness. The particles that once blazed in the hearts of suns and coursed through living veins will settle into their lowest possible energies, their restless jostling finally spent. The fabric of space-time, stretched thin by eons of cosmic expansion, will become a tapestry with no new patterns to weave, no new stories to tell, except, perhaps, those that linger in the memory of those who once wondered. For us, as children of the stars, this prospect is both humbling and profound. We are, after all, creatures shaped by the universe's youth, our atoms forged in stellar furnaces, our consciousness a fleeting ripple in the vast ocean of possibility. Yet in these fleeting moments, we have dared to ask questions that reach beyond the limits of our time, to peer into the deep future with minds sharpened by curiosity and longing. What does it mean, we may ask, for the universe to end? Does the silence that follows its final bow erase the meaning of all that came before? Or does the very act of asking confer its own kind of immortality upon our thoughts? The philosopher's gaze finds in the universe's ending a paradox, an ending without a clear border, a silence that is not mere absence, but a kind of presence in itself. The deep silence that will one day settle over the cosmos is not the silence of nothingness, but the silence of culmination, as if the universe, having played its song, allows the final notes to hang in the air, reverberating through the halls of possibility. In this silence, the questions that have animated our search for understanding still linger, like the after-image of a brilliant light glimpsed through closed eyes. Consider the journey of a single photon, born in the fiery heart of a dying star. It speeds across the universe, slipping past nebulae and star clusters, brushing the edges of worlds that may never know it passed. For eons it travels, its energy stretched thin by the expansion of space, until at last it becomes a whisper of heat, indistinct from the background hum of the cosmos. Its story is one of transformation, of persistence against the erosion of time, and yet also of surrender, of becoming part of something greater, even as individuality dissolves into the whole. So too with the universe itself. Each element, each event, each life is both singular and part of the collective unfolding. The end of the universe, then, is not simply a vanishing, but a return to the deep silence from which all things arose, a silence that is not the negation of being, but its ultimate fulfillment. In the language of physics, this is the approach to equilibrium. In the language of poetry, it is the final stanza of a song still echoing in the mind. From this vantage, our own existence gains a peculiar poignancy. We are, for a brief time, the universe become aware of itself, the pattern that looks back on the tapestry and wonders at its own threads. Our capacity to ask, to imagine, to hope, is itself a product of cosmic history, a fleeting arrangement of matter and energy that, for reasons still partly mysterious, gives rise to meaning and value. The universe, indifferent though it may seem, has nonetheless produced beings capable of love, of grief, of awe, a testament perhaps to the creative potential hidden within the laws of nature. Yet even as we marvel at this capacity, we are drawn inexorably to the questions that persist at the horizon of understanding. What, after all, is the ultimate fate of consciousness, of memory, of meaning, when the universe grows cold and dark? Does the silence that follows the universe's final bow contain, in some hidden corner, the seeds of new beginnings? Or is it, as some cosmologists suggest, a silence absolute and unbroken, the end of all stories and all storytellers? There are those who find in this prospect a kind of existential vertigo, a sense that, if all things must end, then nothing can truly matter. Yet this conclusion is not the only one available to us. The very fact of our questioning, our longing for answers, is itself a source of meaning. In the face of cosmic silence, we become the voice that sings, the mind that remembers, the heart that hopes. Our impermanence does not diminish us. Rather, it lends a precious urgency to our lives, a reason to cherish the fragile beauty of each moment. The philosopher Simone Weil once wrote that two things pierce the soul, beauty and affliction. The universe's ending brings both, an austere beauty in the sweep of its history and a deep affliction in the knowledge of its impermanence. Yet it is precisely this tension that has inspired art, science, and contemplation throughout the ages. The silence at the end of time is not simply an abyss. It is a canvas upon which we paint our questions, our dreams, our acts of understanding. If we turn once more to the science, we find that the universe's final bow may not be quite so final as it seems. The future remains uncertain, veiled in the mysteries of dark energy, quantum gravity, and the true nature of time itself. Some theories hint at cycles and rebirth, at new universes budding from the ashes of the old. Others suggest that the information encoded in every particle and event is never truly lost, but woven into the fabric of reality at a level we cannot yet fathom. The silence, in this view, is not an ending, but a transformation, a passage into realms beyond current comprehension. And so, the universe's end becomes not a wall, but an open door, one that invites us to imagine, to hypothesize, to wonder. We are heirs to a tradition of questioning that stretches back to the first stirrings of sentience, and forward to whatever future minds may arise. Each generation stands on the brink of the unknown, peering into the darkness with the light of curiosity as their guide. The silence ahead is vast, but it is not empty. It is filled with potential, with the residue of all that has been thought, felt, and dreamed. In the quiet that follows the last echo of creation, time itself becomes a riddle. What is the nature of time, when change ceases and all processes come to rest? Is time merely an illusion, a measure of movement and difference, or does it possess a deeper reality, persisting even in the absence of events? The universe's final bow forces us to confront these questions, to probe the limits of human knowledge and the possibilities that lie beyond. There is a kind of grace in this inquiry, a humility born of our awareness that we are not masters of the cosmos, but participants in its unfolding. We are, as Carl Sagan once observed, star stuff contemplating the stars, a brief spark of awareness in the long night of existence. Our insights, our theories, our art and science are all attempts to make sense of the silence, to find pattern and meaning in the vastness that surrounds us. As the universe approaches its final act, the boundaries between science and philosophy, between observation and imagination, begin to blur. We find ourselves drawn not only to the mechanisms of cosmic evolution, but to the meanings that arise from our engagement with them. The silence at the end of time is not a void to be feared, but a mystery to be embraced, a reminder that even in the face of ultimate uncertainty, the human spirit persists in its search for understanding. And so, as the universe's final bow draws near, we are left with questions that resonate across the ages. What is the value of a fleeting existence in a universe destined for silence? Can meaning endure in the absence of permanence, or is it woven precisely from the threads of transience and mortality? The silence that will one day enfold the cosmos is not an answer, but an invitation, a call to wonder, to create, to love, and to remember. In this way, the universe's ending is not a negation of its story, but its culmination, a final bow that gathers together all that has been, all that is, and all that might yet be. We, who have arisen to ask these questions, are part of that story, woven into the very fabric of the cosmos we seek to understand. The silence is vast, but it is not empty. It is filled with the echoes of our questions, our hopes, our awareness, a symphony of silence that endures even as the stars fade and the curtain falls. Somewhere, in the cool darkness between fading galaxies, a memory persists, the memory of a universe that once burned with the light of 100 billion suns, and of the living beings who gazed upon that light with wonder. In the end, perhaps, it is the act of wondering itself that endures, that gives shape to the silence and meaning to the void. The universe's final bow is the beginning of a deeper mystery, a silence that sings, a question that waits, unanswered perhaps, but never unasked. As our journey through the unfolding mysteries of the universe's final whispers gently drifts to a close, we find ourselves cradled beneath a velvet sky where stars fade like a comet tail melting into the hush of space. May your thoughts wander peacefully among these cosmic dreams, and when you're ready, return softly for more Dreamtime tales that illuminate the quiet wonders beyond.